Hello and good day everyone. So welcome back to our next session. This time we are at the cream of the crop of our lectures. Basically this is what CCC100 is all about. Now maybe some of you have already heard about algorithms. Maybe some of you have already tried writing your own programs with different programming languages. But before you are supposed to do that, you need to learn about algorithms and flowcharts, because algorithms serve as a guide or a stepping stone towards writing your programs or applications using different programming languages. The advantage of having to use algorithms first is that you would be able to fully understand what the program is all about before you could actually write it on, or before you could actually write the program itself. And then you could also have the option to write the program on different programming languages as long as you have already understood what the algorithm is all about. So algorithms and flowcharts are two different ways of presenting the process of solving a problem. Algorithms consist of a set of steps for solving a particular problem, while in flowcharts, those steps are usually displayed in shapes and process boxes with arrows. Basically, your flowcharts are the visual representations of your algorithms. Flowcharts are diagrams that visually present the process of solving problems. It shows the logic of an algorithm and emphasizes individual steps and their interconnections. For example, control flow from one action to the next. So the rules of drawing flowcharts for algorithms are the following. First is that all boxes of flowcharts are connected with arrows to show the logical connection between them. Flowcharts will flow from top to bottom, and all flowcharts start with a start box and end with a terminal box. So here are the basic symbols for use in flowcharts. The oval denotes the beginning or the end of a program. The parallelogram denotes the input operation and output operation. A rectangle denotes a process to be carried out, for example, addition, subtraction, division, or any other processes. A diamond denotes a decision or branch to be made. The program should continue along one of the two routes. So this is your if then else. And of course your flow line, which denotes the direction of logic flow in the program. So let's try to look an example. Determine the output whether the number n is even or odd. So for an algorithm, the first step is to read the number n. Then the second step is set remainder as n modulo 2. Then step 3, if remainder is equal to 0, then the number is even. Else, the number n is odd. Then print the output. Kailangan siguro mo kung saan ang modulo, right? Modulo 2. So if the number has a remainder, then it's odd. If the number doesn't have a remainder, then it's even. So to visualize this algorithm in a form of flowchart, this is what it looks like. So you have the start symbol, and then the input, which is in this case the number n, and then you have the process, which is the remainder is equal to n modulo 2, and if the remainder is equal to 0, which is inside the decision box, if it's a yes, then it's even. If it's a no, then the number is odd. Then the answer is printed as output. and then end. So this is the flowchart version of the algorithm that is on the left side. Let's have another example. Calculate the interest of a bank deposit. So first step is to read the amount, and then next step is to read the years, and then next is to read the rate per annum, or the interest, and then calculate the interest with the formula interest is equal to amount times the number of years times the rate divided by 100, and then print the interest. In flowchart form, it looks like this. So the inputs are the following: the amount, the years, and the rate, and then the process box will compute the interest where it's equal to the amount times the number of years times the number of rate divided by 100, and then output the interest. So dali ra kaayos mo tanan. It's really easy to visualize your algorithms as long as you also understand what your algorithm is all about. Let's have another example. Determine whether the temperature is below or above the freezing point. So first step is input the temperature. Then if it's less than 32, then print below freezing point. Otherwise, print above the freezing point. So this is a very simple algorithm, which if you are going to visualize this in a form of flowchart, it would look like this. So the first is the temperature is red, which will serve as the input, so it's inside the input box. And then on the decision box, the temperature is identified whether it's below or above, or less than or greater than 32. So if it is less than 32, then it's below the freezing point. If it's above 32, then it's above freezing point ang iyahang output, and then end. So I hope you understand that one. So let's have one last example. Determine whether a student passed the exam or not. So this is also very simple. The algorithm would look like this. First is you input the grade of, for example, 4 courses, which are M1, M2, M3, and M4. And then calculate the average grade with a formula. Grade is equal to M1 plus M2 plus M3 plus M4 divided by 4. And then if the average grade is less than 60, print fail. Otherwise, print pass. So what the flowchart would look like is this. So you have the input for the grades of M1, M2, and M3, and M4, and then it's computed under the process box. So naadi i-compute ang iyang average, and then under your decision box, it asks if the grade is less than or greater than 60, which is the passing rate of IIT. And then if it's a yes, then fail. No, if it's less than 60, it's a fail. But if it's greater than 60, then it's a pass. So flowcharts are very easy to use, and it's also very easy to understand as long as you already understand. You also already understood what you are trying to visualize. So in this case, your algorithm. So one of the alternatives within an if-then-else statement, which is what is inside your decision box, is it may involve further if-then-else statements. So it would look like this: if the proposition then another if na pod ng statement, proposition then process, else process. So it's a nested nga if and else then statement. Daghan siya nga if then else statement. This is actually commonly used by beginners, for those especially that do not know yet how to use loops or looping in a programming language. I actually have tried using this one, very crude and brute force way of writing a program if in case naa kay mga multiple selections, multiple choices, and then you have different answers that would lead to something na gusto kayo ni mga answers sa imong users. If you have this course, the course ako nakuha before, knowledge base, we actually have a program there written in a series of nested if then else statements. Because when you have a knowledge based program, basically it's a nested if then else statement program. Lots of if then else statement program, because it will ask you a series of questions which are usually binary questions, meaning it can only be answered by a yes or no. It will end up with one of the stored solutions or knowledge on your knowledge database. Okay, so that's it. I am going to post a repository for this activity on Edmodo. So I want you to write an algorithm that reads 3 numbers and prints the value of the largest number. Write an algorithm, not a program. Do not use any programming languages yet. Just an algorithm, and then draw the flowchart of your algorithm. Submit it on Edmodo on the assignment that will be posted. Okay? So if you have any questions, clarifications, comment it on this video. Don't forget to like and subscribe. See you in the next session.